Hello, we are going to move forward with Chapter 12, Section 5. And just a quick reminder, when you add fractions, if the denominator is the same, 3/4 plus 3/4 would add to give you 6/4. You can reduce that to 3/2, which is 1/2. It's probably your best answer, or the most reduced fraction. So when you're adding fractions and when you're subtracting fractions, you have to have a common denominator. Once you have that common denominator, that common thing that they're both out of, then you can put the numerators together. So 5 plus 1 is 6. So if I have 5 pieces of a 6-piece pie, and if I have 1 piece of a 6-piece pie, then I have 6 pieces of a 6-piece pie. Now, I shouldn't have boxed that because that's improper, because it's reducible. So this is equal to 1. So I can't add 1/4 of a piece of pie and 2/3 of a piece of pie. I need them to be the same denominator. So to get them the same denominator, I'm going to bring them both up to 12. So I'm going to multiply this by 3/3. I'm going to multiply this by 4/4. You can always do that. You could always multiply this one by this number and vice versa. But if there's a smaller number you can get them up to, it's better because it's easier. Okay, so this becomes 3/12. And the second fraction is going to become 4 times 2 is 8 over 3 times 4, which is 12. So now I have 3/12 and 8/12, and when I add those together, I get 11/12. So this is a 5. I'm going to multiply this by 5. This right here is a 2. I'm going to multiply this one by 2/2. So I have 5/10 plus 4/10, giving me 9/10. That's not reducible, so we're done. Now, subtracting is the same exact situation followed. So 5/8 minus 1/8 would be 4/8. That's reducible to 1/2. 4/3 minus negative. A minus and negative. I can make that plus a negative. So a minus a negative would be plus a positive. You need to change the sign of what's behind the minus that you're changing. So 4/3 plus 1/3 is really 5/3, which is 1 and 2/3. And then we have the non-common denominator. So I'm going to bring both of these, multiplying by 5, and both of these I'll multiply by 9. So 35/45 minus 9/45 would equal 26/45. And if you have just a whole number, that is the same thing as putting it over 1. So 2/5 minus 1/1, I need to make that over 5. So 2/5 minus 5/5 is negative 3/5. So we're going to apply these same principles to rational expressions. So the first thing I would do is add them. They have a common denominator already. So n plus 3n is 4n. So 4n over 2n. And we can reduce the n, and we can reduce 4/2 to give us 2/1. So our answer is 2. And is this asking us to state excluded values? It's not. Just remember that if by chance n does equal 0, it cannot equal 0, so no big deal. All right, second equation, we have 3y squared plus 3y, which is 3y squared plus 3y, and the denominator is just y plus 1. So the numerator is factorable, so you're going to take out the greatest common factor of 3y, and you're left with y plus 1. And then the y plus 1 is linked together, so the entire y plus 1 can be canceled. The minute you see a plus sign, go ahead and link it together and cancel it. So your final answer is 3y. There is an exclusion of negative 1, so just kind of keep that in mind. All right, this time we're subtracting. Now, I'm going to write the numerator only just to show you this. I'm subtracting this whole thing. I can actually put parentheses around all of these because of the minuses and link them together. So when I'm subtracting this whole thing, I need to distribute that negative through the parentheses. So 5a plus 2 minus 2a plus 4. My numerator becomes 3a plus 6. My denominator is what it is. Now these are factorable. I can take the greatest common factor out, which is 3. And in the denominator, this is the difference of perfect squares. So this is a plus 2, a minus 2. Now, I have an a plus 2 in common. So my final answer is a 3 left on top and an a minus 2 on the bottom. Okay, same exact thing. We're going to distribute this negative to both. So 2b, how about if I just write this out again? So when I distribute that negative, I'm going to make this a positive, this a positive, this a negative. So 2b plus 2b is 4b, and 14 minus 2 is 12. The denominator, b squared plus 3b minus 4. So let's factor. Take out the greatest common factor on top. Every time you have a binomial, that's what you're doing. You're looking for the greatest common factor first, or you're looking to see if it is the difference of squares. And in the denominator, two numbers that multiply to give you negative 4, that add to give you 3, are negative 1 and positive 4. So, can we reduce anything? B plus 3 does not match with a B minus 1, does not match with a B plus 4, so this is our answer. 4, B plus 3 on top, and B minus 1, B plus 4 on the bottom. Nothing can cancel. You have to cancel entire parentheses. What the least common multiple means is what's the smallest thing I can get both of these to so that they're the same. So for example, if this was 1 over 5f squared h, and if I had 1 over 15f h squared, what can I do to make both of those denominators the same? So on the left here, I need to get my number to a 15. So I would need to times by 3 so that my 5 becomes a 15. Now, if you look at the letters, I have an f squared and an f. So this one needs an f. And what you do to the bottom, you have to do to the top. And then for my other letter, h, this is an h squared. This is just a single h, so I need to multiply an h. I need another h. So my least common multiple is the smallest thing that makes these numbers the same. It would be 15 f squared h squared. Now, a long way to do that, or a different way to do that, is to write your factor tree for each of them. So this would be 5, 2 f's and an h. And the factor tree for 15 would be 3 times 5 times 1 f and 2 h's. So you circle everything they have in common. So the greatest common factor, I'm going to go up here, is 5fh. And the least common multiple is the greatest common factor times everything else. So I need to multiply by an f, multiply by a 3, and multiply by an h. So I still get that 15 f squared h squared as my least common multiple. So it's another way to do that if it makes it easier. If we look at the next problem, I'm still thinking of these like as my denominator to get a common denominator. This first thing factors two numbers that multiply to get negative 12 and add to get negative 4. It'd be x minus 6, x plus 2. So this is x minus 6, x plus 5. So to have a common denominator, this first equation needs an x plus 5. So I'm going to multiply by x plus 5. And the second equation over here needs an x plus 2. So I'm going to multiply by x plus 2. So my least common multiple is my common denominator. It's the smallest thing I can get my denominator to. So x minus 6, so that they're the same. X plus 2, x plus 5. So this is kind of a step-by-step least common denominator. So if you have two equations that have a different denominator, before you add or subtract them, they have to be common. So I'm going to need two d's over here because I've got this d cubed. And then my 3 and my 2, I need to get these both to a 6. So I'm going to multiply this by 2 over 2. That's a 6. I'm going to multiply this by 3 over 3. All right, so my new problem is 8d squared over 6d cubed minus 6d over 6d cubed. Now, don't cancel anything yet. We did this to have common denominators to put them together. So now I can put the numerator together. 8d squared minus 6d over 6d cubed. I have a minus. That means this is linked together. I can only cancel that exact thing. So I need to factor. My greatest common factor in the numerator is 2d. So we're left with 4d minus 3. In my head, I'm just kind of distributing it to make sure I'm actually getting that. I'm going to rewrite this whole fraction down here as 2d times 4d minus 3 over 6d cubed. Now, this is linked. It can only cancel with another 4d minus 3. The 2 and the d can cancel with this 6 and the d cubed. So, 2 over 6 is 1 over 3. 1d on top, 3d's on the bottom. That means there's 2 left on the bottom. So on the numerator, we have 4d minus 3. In the denominator, we have 3d squared. Nothing can cancel because of that linked together. All right, the next problem, we need to factor this. So a plus 4, a minus 2. So to get a common denominator, we're going to multiply this by a plus 4. All right, I'm going to rewrite this entire problem below. The numerator needs to be all distributed out so I can put my like terms together. I'm going to leave the denominator factored because I'm going to eventually cancel. So the numerator, a squared plus 4a plus, I'm distributing this, 8a plus 32 putting like terms together, a squared plus 12a plus 32. Factoring the numerator to see if I can cancel something. Two numbers that multiply to give 32, that add to give 12. 8 and 4. So this is a plus 8, a plus 4. I have an a plus 4 in common. I can cancel that. So my final answer is a plus 8 over a minus 2. You're done. Now, if you're looking at that and you think that can reduce to like negative 4, I want you to freak out and listen really deeply. When you have a plus or a minus, it links the two terms together. This is a binomial. A plus 8 can only be canceled with an a plus 8. If you had 8a over negative 2a, yes, you can cancel. You can get to negative 4. You don't have that. You have a linear situation. So you can only cancel that entire binomial, that line, with another line of the exact same thing. Again, if there's no plus sign, anything goes. Once there's a plus and a minus, you are on high red alert, red flag focus, and you are only canceling like binomials with each other. Okay, Tico and Julio cut the lawn at different rates. Tico takes 3 hours to cut the lawn. So his rate is, he gets 1/3 of it done per hour. That means it takes him 3 hours to cut the lawn. And Julio takes him 2 hours to cut the lawn. So he gets half of the job done every hour. If they work together, how long will it take them to cut one lawn? So I have h over 3 plus h over 2 equaling 1. And I need a common denominator. I'm going to times this by 2. I'm going to times this by 3. So 2 hours over 6 plus 3 hours over 6 equaling like a 1 over 1. So 5h over 6 equals 1 over 1. Now, we're going to get into this more tomorrow or the next day. But if you do have a fraction equaling a fraction like this, you can cross multiply. So 5h would equal 6. So 6 divided by 5. So the time it would take them is 1 and 1/5 hours. So 1 and 1/5 hours, if you do 1/5 of an hour is 12 minutes. So 1 hour, 12 minutes. I'm going to stop there. All right, so that was just like a little extra, and I hope you can add and subtract these rational equations with ease and pride. Have a good night.